As urbanization continues to expand, water bodies like this face increased challenge from urbanizations, challenges that include runoff, pollution, and habitats. Understanding these factors and their impact on water qualities is essential for development and management strategies that balance urban development with environmental preservation. Hi guys, my name is Samantha Lopez from the Trinity Water Research Team under the Branchway Incorporation. Today's research will compare and analyze the factors affecting water qualities into urban ponds. Lake Kittamakindi, located in Columbia, Maryland, and Sarah Pond at the University of Baltimore County, or best known as UMBC. Both these ponds serve important ecological and recreational functions for their communities. They are influenced by very different environmental factors and management practices. Both Lake Kittamakindi and Sarah Pond are exposed to environmental stressors typical of urban areas, impermeable surfaces like roads, parking lots, and buildings, nutrients pollutions, and disruptions of natural water flows. Runoff from these urban surfaces can elevate levels of harmful nutrients like nitrates and phosphates, leading to issues like algae blooms and the degradation of water qualities. During the field trip to both ponds, we made some interesting observations, like Sarah Pond, despite being in an urban area, is relatively isolated with limited public access and well-maintained surrounding environment. And in contrast, the Lake of Kittamakindi is situated in much more heavily trafficked urban setting, surrounded by buildings, parking lots, and recreational areas, which might increase exposure to pollutants from human activities. This difference in locations and human activities lead us to hypothesize that Kittamakindi, with its more urbanized and is exposed location, will experience greater degradation and water quality compared to Sarah Pond, which is benefit from its more succulent settings. We predict that Kittamakindi will exhibit higher levels of pollutants such as nitrate, phosphate, turbidity, and potential more frequent algal blooms compared to Sarah Ponds. In contrast, we expect that Sarah Pond it's more isolated and less development settings to have better water quality, lower nutrients levels, fewer signs of eutrophication, and clear water.
Hi, I'm Emma O'Callahan. I'm the research coordinator for Trinity. To carry out this experiment, we collected water samples from two urban ponds, Sarah Pond and Lake Kittamakindi. Each pond offers a unique environment which allows us to compare the effects of urbanization on water quality. We collected water samples from both ponds on separate days, November 3rd, 2024 for Lake Kittamakindi and November 5th, 2024 for the Sarah Pond. To ensure consistency and avoid contamination, we used sterile bottles for each sample and took great care during the collection process. After collection, the samples were immediately transported to the UMBC laboratory for analysis. We made sure to refrigerate the Kittamakindi samples right away to preserve their integrity before testing. In the lab, we performed several water quality tests to assess the pollution levels and ecological health of the ponds. These tests included measurements of pH, nitrate, nitrogen, fecal coliforms, phosphates, and turbidity. We followed the establishment procedures from the Rita Water Analysis Laboratory for each test. For example, we measured the pH to determine the acidity or alkalinity of the water, which can indicate pollution levels. We also tested for nitrate, nitrogen, and phosphates, which are nutrients that can lead to water quality problems like algal blooms. Fecal coliforms were tested to check for contamination from waste, and turbidity was measured to see how clear the water was, which can reveal the presence of suspended particles from pollutants. In this experiment, the independent variables were the water samples collected from the Sarah Pond and Lake Kittamakindi. The dependent variables were the results from our water quality tests. To ensure consistency, we kept the conditions of sampling and analysis the same. We performed the tests at similar room temperatures and times of the day. Additionally, Kittamukundi samples were refrigerated immediately after collection to preserve their components and avoid changes in the water. To summarize, we carefully collected water samples from both ponds, transported them to the lab, and performed a series of tests to measure the indicators of water quality. By controlling for variables and ensuring the stability of the samples, we ensured that our results would accurately reflect the health of these urban water bodies.
Hi, I'm Isaac Song, Trinity's data coordinator, and let's look at the results. From our water quality tests, we collected data from both Lake Kittamukundi and Sarah Pond, and the results provided valuable insights into the conditions of these two urban ponds. First, let's examine the results of Lake Kittamukundi. The pH of the water was 8.3, which is slightly alkaline. Next, we measured turbidity, which came in at 7 FAU. This indicates that the water in Lake Kittamukundi is relatively clear with a few suspended particles or sediments. We also tested for fecal coliforms, and both ponds showed no presence of contamination, with a result of 0 milliliters for Lake Kittamukundi. For nitrate nitrogen, Kittamukundi showed a concentration of 0.9 parts per million, which is low but still detectable. Phosphate levels in Kittamukundi were 0.53 ppm, suggesting a moderate presence of nutrients which could potentially lead to algal growth or other ecological imbalances. Now let's look at the results for Sarah Pond. The pH there was 8.6, which is slightly higher than Kittamukundi's, but within the healthy range. However, when we look at turbidity, there's a noticeable difference. Sarah Pond had a turbidity level of 15 FAU, which is much higher than Lake Kittamukundi. Like Kittamukundi, Sarah also has no detectable fecal coliforms, which is a positive result, indicating that it's free from waste contamination. For nitrate nitrogen, there is no measured nitrate in the Sarah Pond, which is a result of 0 parts per million. Finally, the phosphate levels in Sarah Pond were much lower than Lake Kittamukundi at 0.04 parts per million, suggesting that nutrient levels are relatively low, which could help prevent excessive algal growth. In conclusion, our data reveals some key differences between both ponds. While both are relatively healthy in terms of pH and microbiological contamination, Sarah ponds show higher turbidity and lower nutrient levels, while Kittamukundi has a clear appearance with some detectable levels of nitrates and phosphates. These results highlight the influence of urbanization on water quality, which suggests that natural factors, land management, and human activity all play a role in shaping the health of these urban ponds.
Hello, we are Trinity Water's data analysis. I am Stephanie Rue.
And I am Ronnie Mejia Rivera.
Now that we've seen the results from Lake Kittamukundi and Sarah Pond, it's time to discuss what these numbers mean and reflect on some of the interesting patterns that emerged. We were able to identify key differences between the two sites in terms of pH, turbidity, nitrate, and phosphate levels.
The results reveal some surprises and confirm a few expectations that we had. Let's break it down and discuss these differences, starting with the pH values.
Both Kittamukundi and Sarah showed slightly alkaline pH values, 8.3 and 8.6 respectively. These are typical for many aquatic ecosystems and indicate that the water at both sites is within a healthy range for supporting aquatic life.
That's right, pH values between 6.5 and 9.0 are generally considered safe for most aquatic organisms. In terms of acidity and alkalinity, we didn't observe anything concerning. Both ponds are in good range for their ecosystems.
Now, turbidity was one of the most striking differences. Sarah Pond had a turbidity level of 15 FAU, which indicates that the water is cloudier. In contrast, Kittamukundi had a lower turbidity of 7 FAU, meaning its water is much clearer.
This was a bit of a surprise. Given Kittamukundi's more urban setting, we expected higher turbidity due to increased runoff and human activity. However, Sarah, which we thought might be more isolated, ended up with the mobile suspended particles. This could be due to natural erosion, sediment runoff, or even increased biological activity at Sarah Pond.
Right, and the higher turbidity at Sarah might be linked to geological factors or the type of vegetation around it, which could disturb sediment in the water. This finding doesn't completely align with our initial expectations, but it highlights the complexity of environmental factors affecting water quality.
Looking at nitrate nitrogen levels, we found 0.09 parts per million in Kittamukundi and none detected in Sarah Pond. This is a notable difference.
The presence of nitrates in Kittamukundi could point to pollution from agriculture runoff, wastewater, or even fertilizers used in nearby areas. Nitrates are often linked to
to human activity, especially in urbanized environments.
Well, on the other hand, the absence of nitrates in Sera suggests that it may be less impacted by such urban or agricultural influences. It could also point to more efficient natural filtration processes around Sera. Either way, this difference is significant and tells us a lot about the surrounding land used at each site.
Next, let's talk about phosphate levels. Kinamakundi had 0.53 parts per million, which is relatively high compared to Sera's 0.04 parts per million. Phosphates, like nitrates, are often associated with urban runoff and fertilizer pollution.
That's a good point, Stephanie. High levels in phosphate in Kinamakundi could be contributing to nutrient enrichment in the water, which can lead to algal blooms and eutrophication. This can deplete oxygen levels in the water and harm aquatic life.
But Sera, the much lower phosphate level suggests that it's not being impacted by these sources as much, which could indicate better water quality overall. This may be because it's more secluded from urban areas and possibly more protected from agricultural runoff.
So, overall, our initial hypothesis that Kinamakundi would have more pollutants was largely correct when it comes to nitrates and phosphates. The higher concentration of these nutrients suggests more urban and agricultural influences on Kinamakundi's water quality.
However, the turbidity results were unexpected. Sera ended up with much higher turbidity. This discrepancy points to other factors at play, like natural erosion, biological activity, or soil disturbance in Sera.
One potential error in the experiment is the fact that the samples from Kinamakundi were collected several days before analysis, and they were refrigerated for 72 hours. This delay could have impacted the stability of certain components in the water, particularly sensitive compounds like nitrates and phosphates.
Yes, this is an important consideration. Ideally, all water samples should be analyzed as soon as possible to minimize the risk of changes over time. For future research, we suggest expanding the scope of the study to include a broader range of variables and conducting long-term monitoring to track seasonal fluctuations in water quality. This would help provide a more comprehensive understanding of the factors influencing water quality over time.
It would also be helpful to take samples from various points within each water body. This could give us a more accurate snapshot of water quality and help identify any localized changes in conditions. Long-term studies, especially during high-risk periods like summer, could also shed light on how seasonal changes affect nutrient levels, turbidity, and overall water health.
Additionally, monitoring water quality after heavy rainfall events would be useful, as urban runoff tends to spike during storms, bringing in more pollutants and particles into water bodies. This is a common cause of spikes in turbidity and nutrient levels.
In conclusion, this experiment has helped us better understand the water quality of two urban ponds, revealing some important differences and providing valuable insight into how urbanization impacts these ecosystems.
We've learned a lot, and with more research, we can continue to explore the environmental factors influencing water quality in urban ponds. Thanks for joining us in this discussion, and we hope that with this, we can have more discussion on urban water management.
See you all